Now this is a problem which do consume some time. And I wouldn't do this in the first round. But since it's explanation, I have to do it in the first round, so I'm going to do it. Let both p and k be prime numbers such that p square plus k is also a prime number less than 30. So we already saw the Polo's prime method, or otherwise also you can simply first write down all the prime numbers which are less than 30. The first four you have to know. They are 2, 3, 5, 7, 11, 13, 17, 19. Then we have 29, 23, 23 and 29. These are the prime numbers which are less than 30. So when you are adding this thing, that is p square plus k, I should be getting some numbers out of this list, something out of this list, which are something out of this thing. Now, interestingly, p and k are also prime numbers. Okay, so we have to find all the possible value of k. Now let's look at this thing. See, we have the prime numbers 2, 3, 5, 7, 11, and so on. If I take the squares of them, I'm going to get 4, 9, 25, 49, 121. Now let's look at this p squares value. If p square is the number like 4, 9, 25, etc., you are going to get a sum which is less than 29 or which is less than 30. That's fine. But if it takes p as to be 7, then p square will be 7 square 49. If I'm adding that with any of the prime number, I will never get a number which is less than 30. So p cannot take any value above 5. Okay, so that is the number one thing. P cannot take any value. Yeah, this thing. Now there is two approach. You can substitute this space with any of these values and come to the solution, or you can substitute the value of p square and come to the solution. Should p and k be distinct? No, p, k and k can also be same number. Now instead of substituting here, I'm going to substitute p. So first I'm going to take, let's p equal to 5, therefore p square equal to 25. So I'm going to get 25 plus k is a prime number which is less than 30, which is from this list. Okay, so let it be. Now let's see where I'm going to get. So k is also another prime number. If k is 2, 25 plus 2, I'm going to get 27, which is not a prime number. So k is not 2. K is not 2. If it is 3, I am going to get 28, which is not a prime number. It cannot be 3. If it is 5, it is going to be 30, which is not less than, which is not less. Okay, it is above 30. It's not less than 30, which is equal to 30. It is not less than 30. So it cannot be 5. And any value above that will also come to the solution. So I don't need to substitute. So that basically means P is not 5. Okay. Now let's check the next value. I'm going to say P is going to be 3. If P is 3, P square is 9. 9 plus what? Okay. That is 9 plus K should be some prime number less than 30, right? So 9 plus what? If I put 9 plus 2, I'm going to get 11. Yes, that is a prime number less than 30. So K can be 2. One possibility I got, okay? Now let's substitute. If it is 3, 9 plus 3 is going to be 12. No. 9 plus 5. 9 plus 5 is 14. Not a prime number. 9 plus 7. What is 9 plus 7? 9 plus 7 is 16. Not a prime number. 9 plus 11 is 20. Not a prime number. 9 plus 13 is 22. Not a prime number. 9 plus 17 is 26. Not a prime number. 9 plus 19 is 28. Not a prime number. 9 plus 23 will be, wait, did I just say 9 plus 9 is 28? Yeah, it is. 9 plus 23, that is 32 greater. So that's only possibility when P is going to be 3. K can only become 2. None of the other values generating a prime number. Now let's go for the last case where P square plus K. Let P is going to be 3 is also done. 2. If P is 2, P square is 4. So 4 plus what is another prime number? 4 plus 2 is 6, not a prime number. So no. 4 plus 3. 4 plus 3. Yeah, 4 plus 3, I'm going to get 7. So that is a prime number which is less than 30. So k can also be 3. K can also be 3. Now another possibility, if it is 5, 4 plus 5 is 9, not a prime number. 4 plus 7, ambulance, fire force, what is the sound? Ambulance. 4 plus 7, it's 11. Yeah, so you're getting a prime number. So k can also be 11. So you're looking for the values of k. So k can be 11. We checked with 7. Now let's check with 11. That is 15. No. If it is 13, you're going to get 17. Even that is a prime number. So k can be 13. Right? Yeah. 13 is done. Now what if it is 17? 17 plus 4 is 21. That is not a prime number. 17 is done. 19. 19 plus 4 is 23. 19 plus 4, 23. That's another prime number less than. So k can also be 19. Now let's put this value. 19 is also done. Which is the next prime number? 23. 23 plus 4, that is 27. No. That is not a prime number. And the last value I don't have to substitute, but still, for this time's sake, if I substitute, I'll get 33, which is above 30 and also not a prime number. So there's only 1, 2, 3, 4, 5 values possible for k. Answer for this problem therefore become B. Option B, 5. 27 is 5. Now in this same problem, there is one more thing which we have to observe. See, if we take in some concept of even and odd, you will see that these two numbers are adding to form one prime number. Okay, all the prime numbers other than 2 are anyway going to be odd numbers. Only one prime number is even, and that is this guy. So see, anyway, we are going to add two prime numbers. Even if you add anything to the smallest prime number, you are going to get a number greater than 2. So the result which is going to come here, it is anyway not going to be 2. It is going to be some value above 2. That basically means that it is going to be an odd number. And look at this thing. This number p, if it is odd square means odd into odd. Therefore, it will be odd. So that is, if it is even, if p is even square is even into even, which is anyway going to be even. Anyway, if p is 2, if to p is 2, then p square is also going to be 2 square, therefore even number. If this is an even number, then here it should be an odd number, because even plus odd, only then you are going to get an odd number. So if you're taking p as 2, then you can substitute all these values and check. That's totally fine. But interestingly, if this is going to be any other prime number greater than 2, if p is going to be 3, 5, 7, so on, then it is all odd numbers. So odd square is always odd. If you take any other prime number other than 2, odd plus odd will become even, and you are surely going to get an even number. So you don't have to check that. Even if you're taking an odd number over here, okay, any number other than 3, then you only have to check with the number 2. K can only become the value 2, then only there is a chance of getting prime. See, we even did that over here without knowing that. When we take p as 3, the only value which matched was when k is equal to 2. 9 plus 2 is equal to 11. Now no other value is going to ever match to create a prime number. Even if we are checking here 25, when p is equal to 5, I only have to check if 25 plus 2 is going to give me a prime number or not. It is going to be 27, not a prime. None of the other value anyway will be giving me prime. Just check. Put any other prime number, that is 3. You are going to get an even number which will not be a prime number. So there is a trick for this problem in this way also. The trick is that first thing which you have to know is that p can only take the forms 2, 3 and 5. Okay. Therefore, p square will become 4, 9 or 25. And whenever p is an odd number, you have to check only with k to be 2. 11, 27. Okay, this is not prime. So this is the only combination where p is 3. So there's only one place where k is going to be 2. When p is even number, When it is 4, then you have to check with all the other values of k. That means 3, 11, 13, 19, all of this only can come from this position. Okay, that means when p is 4. Therefore, this is actually the easiest way to do this problem. Okay, but of course in the examination hall our brain will not work like this. We have potato brains in examination hall, so all the most efficient methods will not work, but knowing them is good, because knowing them will actually help you to come to the most easiest methods. That's it, guys. Thank you.